Dear student, I am Dr. Harold Thomas, Professor in Applied Geology, Dr. Hari Singh Gaur Vishwavidyalaya Sagar. Today, in this course, I will deliver my lecture on regional metamorphism of Pelitic rocks, part 3. I will cover this topic under the following heads: stolite zone, kyanite almandine zone, sillimanite muscovite zone and sillimanite orthoclase zone. Hope it will be useful for you. Try to be regular in course. The appearance of stolite is indicator of upper limit of greens phases and beginning of amphibolite phases. The diagnostic mineral assemblages restricted to this phases are hornblende, plesioclase, anorthite more than 15% plus minus epidote, or hornblende, plesioclase, anorthite more than 15 with garnet. The characteristic minerals are stolite, grassolarite, garnet, almandine garnet, diopside, cummingtonite and anthophyllite, sillimanite orthoclase, etc. Disappearance of andalusite and cordierite distinguish Pelitic assemblages of the amphibolite phases from those of the hornblende, hornfels phases of low pressure thermal metamorphism. Zones / subphases: stolite zone, stolite almandine subphases; kyanite zone, kyanite almandine subphases; sillimanite muscovite zone, sillimanite orthoclase zone, almandine subphases; sillimanite orthoclase zone, sillimanite orthoclase, almandine subphases. Stolite zone: presence of stolite along with kyanite is a diagnostic of this zone. Stolite appear in these rocks that are richer in Al2O3 and FeO, poor in alkalis, as shown by Hosek 1967. The reaction is chloritoid plus muscovite plus minus almandine give rise to stolite plus biotite plus quartz plus water, reaction number 7. This reaction was carried out by Hosek 1969, 540 degree centigrade 4 kilobar, 565 degree centigrade 7 kilobar by Hosek 1969, Richardson 1968. Another reaction is kyanite plus chloritoid give rise to stolite plus quartz plus water, reaction number 8, 540 degree centigrade 4.7 kilobar by Richardson 1968, Hosek 1969. Another reaction is chloritoid plus quartz give rise to stolite plus garnet plus water, reaction number 9, nearly 30 degree centigrade higher than the reaction carried out by Ganguly 1969. Pelitic rocks: kyanite, stolite, biotite with muscovite, quartz, plesioclase. Number 2, stolite, biotite, almandine with muscovite, quartz, plesioclase. Number 3, almandine, biotite with muscovite, quartz, plesioclase. Rock of this subphases resembles those of the stolite, almandine, muscovite subphases, except that stolite in kyanite, almandine, muscovite becomes unstable and the pair kyanite, almandine coexist together. This corresponds to the kyanite isograde of Barrow. Stolite is now no more stable. It reacts with quartz in the presence of muscovite to form almandine plus kyanite plus biotite. The reaction is stolite plus quartz give rise to almandine plus kyanite plus water, the reaction number 10. This reaction was carried out by Richardson 1968 at 700 degree centigrade between 4 and 7 kilobar. Another reaction is stolite plus muscovite plus quartz give rise to kyanite plus biotite plus almandine plus water, reaction number 11. 575 degree centigrade 2 kilobar, 675 degree centigrade 5.5 kilobar. Okay, this reaction was carried out by Hosek 1969. The reaction has not been revised by Hosek and probably the temperature given are higher. Thus, the disappearance of sterolite provides the only possibility of differentiating between the subphases zone 1 and 2. It is evident that the critical association kyanite plus almandine are now possible, which give subphases its name. It is also obvious that in this subphases, kyanite is much more common as compared to the sterolite almandine subphases or sterolite zone, because the range of chemical composition from which kyanite now form much larger here. Mineral assemblages or mineral paragenesis. The characteristic peltic assemblages are: number 1, kyanite almandine biotite with muscovite quartz plagioclase. Number 2, kyanite biotite with muscovite quartz. Number 3, almandine garnet biotite with muscovite quartz plagioclase. The mineral assemblages of these zone/subphases are similar to the kyanite zone. Here, sillimanite is replaced by higher temperature Al2SiO5 polymorph sillimanite. Replace kyanite by sillimanite in all diagrams. This has been experimentally studied by several workers, amongst them the coarse and triple point of Al2SiO5 by Holdaway 1971 is widely accepted. The conversion of kyanite to sillimanite take place within the stability range of muscovite plus quartz, so that muscovite can coexist with sillimanite. Kyanite give rise to sillimanite. Mineral assemblages. The typical peltic mineral assemblages is sillimanite, almandine, biotite, muscovite, quartz plagioclase. Number 2, sillimanite, biotite, muscovite with quartz plagioclase. Number 3, almandine, biotite, muscovite, quartz plagioclase. In this zone, muscovite, which was present throughout the range of metamorphic phases from green schist to sillimanite muscovite zone of amphibolite phases, now become unstable. It is with the breakdown of muscovite that the sillimanite orthoclase zones are begins. The following reaction take place: muscovite plus quartz give rise to orthoclase sillimanite plus water, reaction number 12. This reaction was carried out by Day and Chatterjee 1974 at 595 degrees centigrade 1 kilobar, 640 degrees centigrade 2 kilobar. Another important thing is KAlSi3O8 polymorphs of microcline is also transformed to higher temperature orthoclase. Furthermore, under the PT condition of this zone, partial melting or anastasis of peltic rocks take place, as demonstrated experimentally by Tuttle and Bowen in 1958 and Winkler 1974. The assemblages are: some typical peltic assemblages are listed on the screen. First, sillimanite, almandine, orthoclase, quartz, plagioclase. Second, sillimanite, biotite, orthoclase, plagioclase, quartz. Third, almandine, biotite, orthoclase, quartz. Fourth, biotite, orthoclase, plagioclase, quartz. I will proceed under the following heads: hornblende gammalite phases and pyroxene gammalite phases, zone/subphases, and summary. Hope it will be useful for you. Try to be regular in course. Gammalite phases is a very high grade metamorphic phases in which muscovite is replaced by potassium feldspar and coexisting with Al2SiO5 polymorph sillimanite. Characteristic minerals: presence of hypersthene, garnet, gracilorite less than 20%, pyrope nearly 55%, potash feldspar, sillimanite is indicating the gamma-lite phases, where all amphiboles are absent. Perthite is a characteristic of gamma-lite phases. This phases oblique subphases is gradationally to the sillimanite potash feldspar zone of the amphibolite phases. The assemblage hornblende, plagioclase, diapside belong to the amphibolite phases, where hornblende, plagioclase, diapside, hypersthene represent gamma-lite phases. The rock may contain biotite and hornblende. The typical basic assemblages are clinopyroxene, orthopyroxene, plagioclase plus minus garnet. Cordierite is constituents of some pelitic gamma-lites, especially biotite bearing gamma-lites. The reactions are, the important reaction in gamma-lite phases are biotite plus sillimanite plus quartz give rise to garnet plus potash feldspar plus vapor, the reaction number 13. Another reaction is biotite plus quartz give rise to orthopyroxene plus garnet plus potash feldspar, reaction number 14. Next is your biotite sillimanite plus quartz give rise to cordierite plus hypersthene plus potash feldspar plus water, reaction number 15. All these reaction involving hornblende, amphiphyllite, biotite are divergent on according of varying FeMg ratio and also condition of PS2O less than P total. The reaction start at certain temperature, but all equilibrium phases will be present over a temperature range until with rising grade hornblende oblique amphiphyllite biotite disappear. Thus, two subphases hornblende gamma-lites and pyroxene gamma-lites are recognized. First, hornblende gamma-lite subphases in which hornblende and biotite are present with water. Second, pyroxene gamma-lite subphases with absence of hornblende and biotite are less amount of water. Hornblende gamma-lite subphases. The assemblages are first sillimanite, garnet, plagioclase, quartz, potash feldspar with graphite and rock type is known as condylite. Second, quartz, potash feldspar, hypersthene, garnet, plagioclase, garnetiferous acid charnockite. Third, hypersthene, perthite, quartz, plagioclase plus minus biotite, acid charnockite. Pyroxene gamma-lite subphases at a still higher pressure temperature condition and reduce water activities, the mineral biotite and hornblende become unstable and their relation with different minerals metabolite assemblages give rise to the formation of cordierite and garnet as follows. Biotite plus sillimanite plus quartz give rise to garnet plus potash feldspar plus cordierite plus water, reaction number 16. Another reaction is biotite plus quartz give rise to garnet plus hypersthene plus potash feldspar plus water, reaction number 17A. Another reaction is biotite plus quartz give rise to cordierite plus hypersthene plus potash feldspar plus water, reaction 17B. The formation of hypersthene plus sillimanite by the reaction indicates the higher pressure temperature condition of progressive regional metamorphism. Cordierite plus garnet give rise to hypersthene plus sillimanite plus quartz, reaction number 18. The mineral Mg cordierite has maximum stability of 10 kilobar in water bearing pelitic system, where Fe cordierite has low pressure stability. The reaction is Fe cordierite give rise to almandine plus sillimanite plus quartz, reaction number 19. All these reaction number 1 to 19 are shown on the screen on PT graph for progressive metamorphism of pelitic rocks. The assemblages are pelitic and quartzo-feldspathic assemblages. Sillimanite, perthite, quartz, plagioclase, graphite. Next, hypersthene, perthite, garnet, plagioclase, quartz, hypersthene, perthite, quartz, plagioclase, acid charnockite. Summary. Dear student, today in this lecture we have discussed about the regional metamorphism of Pelitic rocks. I have covered this whole topic in 4 parts. Thus, on the basis of the detailed study of different zones and subphases and along with the support of experimental data, we can conclude that during regional metamorphism of Pelitic rocks, slate, phyllite, schist, gneiss, pegmatites and gammolites rocks are formed. I believe this lecture was useful for you. For further studies, please read the textbooks, references and links given in the text. Thank you very much.